Greetings, the Astro 30 here yet again, and welcome back to AEL. Now, if you're new to this channel, please consider going down below and subscribing if you haven't done so already. Cheers! Well, my AEL-2011 power amplifier revision C boards have turned up. Third time lucky, as they say. So I'm going to get one out and we're going to have a quick look. And I'm going to assemble this off camera, and I'm going to recycle some of the hardware components on the other boards because there's nothing wrong with them, such as capacitors, fuse holders, the trim pots, etc. And I'll just put new transistors on it and resistors. So there it is there. It looks pretty much the same as the others, although I have thickened the pads around the output transistors just to match up with the thickness of the traces on the other side. And the missing route is now included. All should be good with the world. I have double checked this routing several times before I committed to paying for it, and it is routed correctly. So I'm also going to recycle the 0.22 ohm 5 watt resistors off of one of the other boards because there's nothing wrong with them either. And I have also moved this BC546 closer to the BD139 by another ½ a millimeter, so that its body should be in contact with the body of the BD139 without actually having to squeeze them together so much. So you shouldn't even have to use a zap strap. So alright, I'll get set up to start assembling this, and yeah, I'll come back after it's assembled before I've actually put the output stage together, because I've got some new transistors for that. The other board that I built that had the missing route, I will pinch the output transistors off of that board and build a second channel if I so choose to do so, because I've got the bracket drilled for it, because there's nothing wrong with those transistors. But BD139s, 140s, etc., and the BC546s and 556s, I'll just use brand new transistors. I'll also use my component tester to check HFE, especially at the input stage area, just to make sure that they're closely matched in HFE and we're not going to have any weird problems like I did with that MOSFET amplifier. So alright, I'm going to get going on that, and when I've got some progress, we'll come back. Well, I arrive at a friend's house only wearing one shoe. A couple of hours, somehow I've got two. No, seriously, a couple of hours later, I've got the module assembled for the most part, apart from the output stage. The assembly is pretty much the same as the original two failed boards. And with that VBE multiplier transistor there and the driver, it's not quite touching it still. There is still about probably ½ a mil gap between the two devices, so they're just slightly bent over at angles. Someone suggested putting a piece of heat shrink over the two transistors here. Problem is getting heat in there directly. Maybe a hairdryer would work better, and I wouldn't want to use a lighter because you'd run the risk of melting or charring other components around it. So for now I'm not going to worry about it too much, but a little later down the track I'll worry about maybe trying that out. So this is ready to go on to the heatsink bracket, and the output transistors mounted. I'll spare the details of that because I've already mentioned it several times in several different videos. So I'm going to take the TIP 35 and 36C transistors off of the bodge wire second revision PCB because there's nothing wrong with them, and install them on this board onto the bracket, and then we'll come back in just a second. And just like magic, there it is there, isolated and mounted to the bracket. So the first thing I should really do is make sure that our transistors are isolated from said bracket, because we do not want to short the collectors together, because this is a C-clay output, so the emitters are the positive and negative rails respectively, the collectors are the output. So if the collectors are shorted together, well, it's probably not going to affect the output so much because of the resistors, but if this was in a grounded case, well, we're bringing the output down to ground, so shorting the amplifier out. So we've got continuity to the bracket. We should have no continuity between the bracket and each collector, which apparently we do not. So that's nicely isolated. Now these collectors should be connected together via a resistor, which we have. These collectors will be, and these are going to the output via these two resistors, so they will also give you continuity. That's perfectly fine. But the emitters on this side should be connected, but not to this side. So it's no continuity. So that's indicating that the power supply rails are not shorted together. Of course, these two emitters are going to be joined together via the degeneration resistors, and these two emitters joined by the emitter degeneration resistors on that side. But so far, it's looking good. I can now begin the preliminary power up test, and it's beginning to make me feel all nice and goosebumpy. Anyway, no, I should hook this up to a plus minus 30 volt supply, current limited to around about 100 mA, I think will be good enough. And just verify what the DC offset is it adjustable, and what the bias voltage or current draw is at idle, and is the bias adjustable. So that's the next thing I'm going to be doing. And so I'm hoping this works. It should work. I expect it to work, and that's why I've got third time lucky printed on the back of the rear silk screen here, if you can just read that. And it does look like the circuit board is slightly not square with the edge of the bracket. Once I've tested it, I might undo the bolts and just massage it sideways a bit so it's a bit straighter, but I don't know if that comes up on camera very well, but it is not straight. But yeah, it is what it is. So let me get set up for testing this, and if it passes the first power up test without any issues and the bias adjusts, the offset adjusts, we'll load it, put a signal through it, see if it amplifies. Alrighty then. Alright, the power amplifier module is connected to the heatsink with a G-clamp and hooked up to the power supply, with my multimeter going from the output to ground to measure things. Got a nice glass of Coke instead of coffee this morning. Well, LA ice, please excuse me. Nice. The first thing I'm going to do is I'm going to make sure that the bias pot is close to minimum resistance. I mean, well, it doesn't get turned far because these came off of the old non-working boards, so they haven't been turned that far. But we'll just make sure that it's, like, you know, as close to no bias as possible. If I get the screwdriver in there. Ah, come on. Come on. Right, that should be good enough. Okay, supplies are set at plus minus 30 volts roughly. Now I'll turn them on. Oh, look at that. 7 mA of current draw. Nothing really spectacular. As for what the output is doing, well, we got 54 minus millivolts there. So I'll see if by turning the trim pot we can trim that out, if I can find a way around the tripod. Just give me a second. So we'll just do it that way, a little bit sideways, that's fine. I'll turn it clockwise, see what happens. Oh, it's actually going up by the looks of things. Yep, okay, so I'll turn it anti-clockwise, and it is actually coming down. Yeah, it's coming down, and down, and down. Almost there. It's very finicky. This multimeter ranges too quick, so it can be hard to get it to zero, but I'm going to say that's close enough. Now let's see if the bias adjusts. So I'll turn the bias pot and you can watch the power supply's current meter. Turning the pot, there it goes, it's starting to go up. Good. 24 mA. I'm going to ballpark this at around about 30 mA seems fine, 39, something like that. I'll let it stabilize a minute and see what the output is doing and the bias, and then adjust accordingly. So I've let it sit for 5 minutes and it has crept up, so I'll just trim that back out. That's to be expected because it's now stabilized. So I'll drop it back down to about 36 MA, somewhere there. About there's good enough. DC offset seems to be moving around a little bit. So far it's behaved first time out of the box. There's no unusual current draw, the bias adjusts, the offset adjusts. Next question is, does it produce a signal? Well, that's the next test, is to load it into first 8 ohms and then finally into 4 and see whether or not it actually works as an amplifier. 8 ohm dummy load is connected to the output in place of the multimeter. I'm going to set my current limit for about 2 amps, and I'm going to do the same on the bottom. That should be about right, and turn him on. Oscillator is also connected. Good current draw. Helps that the scope was turned on. Alright, so let's turn the gain of the oscillator up. And yes, we do. We have an output, and we've reached clipping, and we haven't reached current limit, which is good. Drawing about an amp, all well and good. Pushing 18.2 volt RMS, which is going to be roughly about 33 watts, which we already know. So, well, if you watch the previous videos. So, without turning this off, I'm going to load it into 4 ohms and run the test again. Okay, so I'll increase the gain. Yes, we have an output. And we're reaching about 14.4 volt RMS, which I think from memory was around about 46 watts. No, it was 51 watts, that's right, which is good. What was the other one? 18.2. Not that I can remember, so I will switch this back to 8 ohms and I'll run the test again just to see what the output voltage was. It was about 18.2, okay. I have a shocking memory, that's 40 watts. So there's about an 11 watt difference between 8 and 4 ohm loads. So that's not bad to get 40 watts out of a plus minus 30 supply. So I'm thinking that this, at the end of the day, should produce 50 watts into 8 ohms and easily close to 80 watts into 4. But that'll be tested later in another video when I've got a power supply suitable for it, to actually run the power test again and see if the transistors don't blow up. Alright, well, as that passed that test with flying colours, it seems to output power nicely into 8 and 4 ohm loads. It would seem a little bit kind of, you know, a shame that there's nothing to put here, like a second module. Or is there? Well, it just so happens I have an identical one soldered up. So we now have two. The only thing I have to do is solder in the output stage to this, and this should line up even though that board's crooked. Yeah, that'll line up fine, so it doesn't really matter that this board on the left here is a little slightly skew-if, so I'll solder up the output transistors on that. I might film that as well so you can see how I'm isolating and soldering, etc. And then we'll put this through its tests, see if this one passes. If it does, we now have a working stereo pair, and then I'll figure out a way of hooking up the supply together so we can run both modules into two speakers and finish this video off with a sound test. I haven't quite figured out how I'm going to do that yet. I still can't really test this at the full plus minus 35 volt supply yet until I get an adequate power supply. But let me get going on putting on the output stage on this channel and setting it up ready to test. And just so everybody knows, I borrowed the resistors and hardware components, including the capacitors, and that one's kind of soldered at an angle, off of the other board that had the bodge wire on it, and I just used new transistors and semiconductors and resistors, etc. And I did do my best to match all the PNPs and NPNs to each other when putting them on each of these boards, so we don't have any issues. Here's the last two boards. The revision A is in my left, and the revision B with the bodge wire on the back there is in my right. So it's been stripped of its 0.22 ohm 5 watt resistors, fuse holders, spake terminal connectors, and the electrolytic capacitors. Why not? They still work, so yeah. Speaking of, I might hit that with the soldering iron again and actually straighten it because it's starting to annoy me. That's better. Very nice. Okay, on to putting the output stage on. Okay, I got all the stuff I need to install the output stage. I've got some TO3P isolation washers and the 2 sets of output transistors. So I'm going to find out what I did with my pliers. Pull this rubber bung out. Now these are the TIP36C, so they go on the right hand side, so these are the TIP35. So I'll do each pin individually, so about that much. And I'll do the same to the other 2 leads. And then just give it a slight little push with my finger or thumb, and then when that goes in the board, that should line up with the holes, well, the hole in the top there where the transistor goes, just by giving a gentle nudge downwards to make it straight, and it lines up perfectly. So now I've got to do that 3 more times and mount it on the heatsink bracket. Okay, they're in now and they're in the right places. These sill pads are as straight as I'm going to get them. That one's a little bit, how you doing? And doesn't really want to move now. Yeah. Good enough. Alright, so as I always say, tighten the screws before soldering. So that's exactly what I'm going to do. And finally the last one. Okay, that's tight. Now I am ready to solder them. There's just enough sticking out. Go down the line and just solder them. Okay, that's soldered, and this right hand side module now is ready for testing. But first check obviously is to make sure that those transistors are indeed isolated, and the battery in the, I was going to say phone, but the battery in the multimeter is going flat. Okay, there's continuity there to the bracket. Collector, nothing. Collector, nothing. Collector, nothing. Collector, nothing. Good. Those 2 are connected. Those 2 are connected, and those 2 are connected. Those 2 are connected. Those 2 are connected, but these 2 shouldn't be, which they are not. Excellent. So now to put it back onto the jig or the heatsink and test this module. But first, obviously, make sure that this bias pot is rotated fully in the anti-clockwise position. Okay, let's get going. I actually thought I'd killed that power supply, by the way, at the bottom, because I thought it was dead. The display was off, it was not making a noise. Because I thought I disconnected the amplifier with the 2 channels turned on because they were still in the on position. No, I just turned the main power switch off. Duh. Supplies are limited back down to roughly 100 mA. I'm not sure what the bottom one's limited to, but it's down. It's connected up across the second module with the multimeter going off the output. And so I'll turn the power on, see if there's anything unusual. No, 7 mA, so the bias is minimum. We've got about 15 millivolts there of offset, so it's in the positive direction, so that means I've got to rotate the pot clockwise, I believe. Yes. Okay. It's coming down, so that's good. Sign. So the input stage on that side is working. There's roughly 0. Now for the bias, see if that adjusts, which it should. Oh, there it goes. It's coming up. There it is. Excellent. So I'll set that roughly to 36 or 35, thereabouts. I'll let that sit and cook for 5 minutes. So after 5 minutes it has crept back up again, which is fine. It's going to do that. So I'm just going to back the bias off again, back down to Well, that was easy, 35 MA. And now I'm going to load it first into 8 and then into 4 and do the previous tests on the first module again on the second one. Alright, it's loaded. Power supply set to a current limit of 2 amps. So I will power it up. Well, the bias has dropped off to 19 MA because it's cooled down, that's fine. Oscillator is connected and running, so I'll just up again. There we go, got an output signal. And there's clipping. And we're roughly pushing the same output. Excellent. Change this over to 4. Really should power the thing off before doing this, but as long as you're careful, it's fine. Okay, we're loaded into 4. Up the gain. Got a signal. There's clipping. And we're pushing roughly the same amount of power into 4 ohms on the second module. Excellent. Well, it's passed those tests, so I might turn it off. And now, well, I'll connect it to a speaker. I'll start with the second module, because, well, it's already connected to the power supply, etc. Remove the load, put a speaker in place of it, inject an audio signal in place of the oscillator, and see if we get a sound output. Right, speaker's up on the desk, but the positive side is not connected. I've actually connected the speaker backwards anyway. Let me try that again. Connect the ground to the negative of the speaker, not the other way around, or else it'll be out of phase. Okay, turn the supply on, and now I'll connect the speaker. A bit of buzz there. That's just input leads. Alright, so I'll play a track. No idea what this one sounds like. Sounds alright, but I don't know the song. Okay, let me now swap to the other channel without changing the volume or the track, and we see if it comes out at the same level. Just give me a minute. Okay, channels swapped, nothing is shorting. Turn it on. Okay, connect the speaker. So a bit of buzzing going on there. If I can get the lead on. There we go. Just input noise. Right, I'll hit play. Okay, that's enough of what sounds like a space cat. Well, a space cat being strangled in a spacesuit. So it's passed all its tests. The bias current of that one's currently up to 40 mA, but that'll probably change once the output stage cools off a bit. Even me just touching the output transistors making it drop. It didn't appear, and it doesn't appear these are getting hot at all, so it's not going in the thermal runaway. Excellent. So let's conclude this video. Alrighty, so it's passed all its tests and it didn't blow up yet. So what's next with this? Well, I need to design a PCB for the power supply that's going to power this, and then do a proper test at plus minus 35 volts DC and see what power output we get into 8 and 4. And having said designing a power supply PCB, I already have one here, which was delivered in the same batch as these new PCBs. So this will be featured in an upcoming video, which will be the next video that I upload anyway. I might as well stick to the same project as I'm going. Assembling this and testing it and explaining a few things about the design changes, because it has a speaker protector on it as well, which I used that simple DC speaker protector that I have a video on in my channel, but I had to make a couple of modifications and I'll explain that why in that video. So the PCBs for this are not going to be available in the description of this video yet, until I've actually done the power supply video, and I'll release both PCBs as shared projects on PCB Way at the same time. So if you want to say build one of these amplifiers, they only cost $5 for 5 PCBs, and you're not subscribed to the channel, subscribe now, because when I release the projects I will put a post up on my channel just saying that they're available. Then I'll update the description of this video, and both PCBs will also be available in the description of the power supply, assuming that it works. But anyway, I'm going to end this video here because there's not much more to talk about with it. It's functioning fine. I'm happy. Third time's the charm, as they often say. And in this case, it was. So I now have a working prototype. And excellent. By the way, these output transistors here come from DigiKey. So if you want a good source of transistors that are not going to be fake, DigiKey all the way. Mouse is okay too. What gets you with DigiKey and Mouser is the $24 delivery fee, but I don't know about Mouser, but with DigiKey, if you order over $60 worth of componentry from them, well, shipping's free. So when I ordered these, I made sure I was ordering other stuff as well to get over the $60, so I was only paying, in the end, probably for the total order, $70 with free shipping, and it's win-win. So yeah, that's going to be it. Winner, winner, chicken dinner, as Dave Jones says. Alright, I'll see you in the next video. I'm the Astro 30, and if you enjoyed this video, please remember to go down below, like, comment and subscribe if you haven't done so already. And as always, this is the Astro 30 saying see ya, thanks for watching, have a great day.